So the first thing we're going to do is we're going to write out what is a proportional relationship. So we're going to get a little definition here. That is absolutely right. It's not what we're going to write because that's a little basic of a definition.
Wait, he's actually right?
Well, I mean, yeah, but we're going to go a little bit more in depth than a relationship that's proportional because that doesn't tell me anything, right? So proportional just means when I'm going to write it, you guys will copy it, and then we'll talk about it. Does that sound good? Because writing and listening is hard at the same time. So stay with me, write while I'm writing, and then I'll talk while you're listening. If that makes sense. Looks like most of us are there. So proportional. Can I get a volunteer to read this definition out for everyone? So it's not me talking all the time? Sure, Eli.
When two sets of numbers have a constant ratio with each other.
Perfect. Thank you very much. Who can tell me what does constant mean? Dylan, what is constant?
All the time.
All the time. The same, over and over again, right? If your friend is just constantly talking about their problems with their boyfriend, what does that mean? Does it mean they only mention it once and then never again? No, it means they're talking about it over and over and over and over again, right? They're constantly talking about this. What is a ratio? Sounds familiar.
I forgot.
You forgot. I love the honesty. Did anyone remember what a ratio is? Yeah, Alicia?
It's a number to another number. Like if there's three people, no, like if three girls and then three boys, it's three and then three.
Exactly, right?
Good job.
So this is a ratio of 3 to 3, right? If there's 3 boys and 3 girls in a room, it's 3 to 3. If there's 1 teacher and 2 students, it's a ratio of 1 to 2, right? Now in elementary school, we typically see ratios written like this with a little colon. But nowadays, what we're going to see is a ratio that looks like this in a fraction, okay? So 1 over 2, 2 over 4, 3 over 6, 4 over 8. What do you notice about all 4 of these fractions here? Ray, what do you notice?
X is multiplied by 4, and Y is 2 plus 6, 8. So 1 is multiplied by 2, and 1 is counted by 1.
Yes, so the X's are counted by 1s, the Y's are counted by 2s. I love it. That's a great observation. Alicia, what do you notice?
You add 1/2 every time.
Okay, we're increasing by 1/2, right? This is 1 over 2, then 2 over 4, then 3 over 6. Good morning. Oh, yeah, you got more? Yes.
They all equal 1/2.
Exactly, right? They all equal, thank you. All these fractions equal 1/2, right? If I cut a pizza into 2 slices and eat 1 of them, I ate half the pizza. If I cut it into 8 slices and eat 4 of them, I still ate half of the pizza, right? I ate more slices, but they're all smaller slices. You know what I mean? So these are what we call equivalent fractions. Everybody go ahead and write that off to the side. Equivalent fractions. So we have two sets of numbers, x's and y's. And the ratio between the x's and the y's is constant. It's 1/2, 1/2, 1/2, 1/2. That's what a proportional relationship would look like, okay? And then Diego, you have your notebook? Yeah. This is the very start of it, so if you want to leave a little bit of space, I can bring this over after and come back to you, okay? So that's what a proportional relationship looks like. We're going to see it in a little bit different of a light, but that's the idea behind it, right? Now, if I had 1/2 and then 1/3, that wouldn't be proportional because they're not the same, right? Anyway, so yeah, these are ratios. They're equivalent. That's good. Constant. And we could say constant, just so we remember, means repeating over and over in the same pattern, like we said. I'm going to drop this down a little bit. There we go. Okay. So we're going to talk about this idea of the letter K. Okay, and what K stands for, welcome back, is the constant of proportionality. It's a hard word to spell, so take your time. Thank you. Represented by the letter K.
Do you like school?
Question? No? Okay. Yeah.
Is it funner being a student or a teacher?
We're going to focus on this.
Dang.
Okay. So, in this example up above, right, the constant of proportionality would be the ratio from y to x. Okay? I'm going to write that over here too. The ratio of y to x. All right? Okay, guys, can we please stay focused on this? You guys are doing really good, but I want to keep us together, all right? So the formula for finding K is very, very simple, all right? It goes like this. K is equal to y over x. K is equal to y over x. It's the ratio of y to x. Do you mind closing that?
Yeah, sorry.
It's the ratio of y to x. So my y is going to go on the top. My x is going to go on the bottom, right? Like we saw up here, if we were going from x to y, it would be 1 to 2. So we got to think of it kind of flipped around. The ratio from y to x is 2 to 1, okay? And there's a very, very easy way for us to remember this phrase, or not this phrase, this equation, and it's with the phrase, why aren't you over your x? Okay? Everybody say that out loud. Why aren't you over your x? Okay, I'm going to let you write for 10 seconds real quick. Because there was like 2 people saying it. Okay, I'm hoping we can be mature about this, right? Because this is a good way for us to remember this. Right? But we don't need any like inappropriate comments or anything like that. Repeat after me. Why? Aren't you over? Okay, that's like 4 people. Everybody repeat after me. Why?
Why
Aren't you over
aren't you over
your ex?
your ex?
Why aren't you over your ex? Go.
Aren't you over your ex?
Okay, that's fine. Why aren't you over your ex, right? We're going to put Y over X. That's how we're going to make this stick in our brains, all right? Because when you see the numbers, and we'll get to an example in a second, your X's are going to be on top and your Y's are going to be on the bottom. So in our heads, we have to consciously decide, I need to flip this around and put my Y's over my X. So just remember the phrase, why aren't you over your X? It wouldn't make sense for me to say, X, aren't you over your Y? That doesn't make any sense. Why aren't you over your X is how we're going to remember this equation. Okay? So we're going to get a little piece of paper that we're going to glue in here. So make sure you still have your glue sticks in front of you. There you go.
Bless you.
I'm going to show you where to glue this in real quick, actually.
Oh my God, I'm being
I'll get this passed out in just a second. I'm going to show you where you're gluing it in.
Crappy in here. Can you stop? Wait, can you stop talking?
Okay, guys, let's stay focused, please. So you're just going to glue this in on the left-hand side if you have room. If you need to flip the page or something, that's fine. Yeah, that's here. I know, I'm sorry.
The hair.
Okay, I don't want to have to move you guys. Stay focused. Stop talking to each other.
I don't want to have to move you.
Is there a problem? We're good.
Can you zoom out for a little second so I can see what happened?
I'll give it to you after. Just leave space. Okay, I'm going to give you guys 30 seconds to get this glued in. Some of us already got it glued in. That's great. Where's your notes?
I don't know where we're at.
Are these?
I'm assuming this or this,
Okay.
and then
We're going to start right here. Okay. Go ahead and read some right down left and right. Okay.
ragged. Oh, smells like oil.
So you took both?
Yeah. You guys give Diego a glue real quick. Thank you. All right. So we're going to take a look at this graph here. All right. What does it say down here at the bottom? Number of hours in the car. What does it say over here? Number of miles traveled. Give me a thumbs up if you've ever been on a road trip with your family before. Anybody ever get in the car and go somewhere? Okay, that wasn't the question, okay? So you got to stay with me and stop being weird, please. Okay? It goes for multiple people, okay? So if you've been in the car with your family, right, you know that it takes a while to get anywhere. Now, you may have gone somewhere close like San Francisco or something like that. Maybe somewhere far like LA. There was one summer my family got in the car and drove to Dallas, Texas. Anyone know where Dallas, Texas is?
3 days away.
Is it close to where we're at right now? No, it is not. Okay? It was like 3 full days of driving. It takes a long time, right?
What did I tell you?
So, what we have here is a graph, right? You guys have all seen graphs before, yes? Okay. Now, you guys listening to what I'm saying?
Yes.
Okay, I could just talk about boring math stuff, but I want to incorporate some things that you guys might understand, right? But we got to be able to snap back and talk about this, okay? So, we have a graph here, right? Now, whenever we have a graph, there's what's called an axis, right? What do we call the two axes? X and Y, right? So we've got this flat axis, and we've got this tall, straight up and down axis. Which one of those is the x-axis, right? Which one's the x?
The bottom.
The bottom one, the flat one. So right next to that, 6, or actually, next to hours in the car, we're going to write parentheses x, because my x-axis is horizontal, which means that my number of miles traveled is which axis? The y-axis. So I'm going to write y in parentheses, just like that, okay?
Mr. Church, do we have to write the y sideways?
You can write it up, straight up and down if that's better for you, okay? So the hours in the car is my x. The number of miles traveled is my y, okay? What we're going to do is we're going to make a table
You have your Chromebook open.
that shows this data. Okay, so off to the side, we're going to make a little table.
Close that Chromebook.
I'll give you guys some time to construct this graph because I know some of us want to make it perfect, like me. Good looking tables back here, some of us still drawn. Good. These are quick. Gianni's already ahead of me. Let's see if it's right. Probably is. So, on the very top of my table is going to be my x, right? X represents the number of hours in the car. So if we look down here on the x-axis, I did mine in orange. We see 1, 2, 3, 4, 5, 6. What does that number represent? Is that the number of cars?
Hours.
No, it's the number of hours, exactly. And on the y-axis here in this little like tealish green, we see that we've got 60, 120, 180, 240, 300. What do those numbers represent? The number of miles, exactly, right? So if we look at point A, right? Where does point A line up on the x-axis? Dylan, where does it line up on the x-axis?
60.
The x-axis.
Oh, the 1.
The 1. You're good. Yeah, it lines up at the 1, right? So at the 1,
Looking at
at 1 hour in the car. And then you said it lines up where on the y-axis, Dylan?
The 60.
The 60. Notice how I skipped a box. That was on purpose. All right? So after 1 hour in the car on this little road trip, you've driven 60 miles.
That means you're going
Okay.
60 miles an hour.
Perfect. Now, if you've been in the car for 0 hours, how many miles have you traveled?
0.
0.
You just got it.
Right? That's this point right here. Anyone remember what we call that point down there? It's got a special name.
The origin.
The origin is correct, right? This little point right here, we're going to write that in. It's called the origin. Yes?
What if you travel for like half an hour?
Well, we can take a look at that, right? Between 0 and 1, here's half an hour. We look up to the line. We look over. What's directly in between 0 and 60? 30. So in half an hour, you could have gone 30 miles. This graph tells us all the information we need. That's a great question. We're going to leave that point off. Okay? If we look at point B, where does point B line up on the x-axis? If I look straight down to the x, where does it line up? 2. If I look over to the y-axis, where is point B at on the y-axis? 120. So how many miles have you traveled in 2 whole hours? 120 miles, right? We're just getting practice understanding what we're even looking at, right? Because we're going to see graphs tomorrow that are going to have some words down here, some words over there, and we got to figure out what it's even talking about, all right? So point C, if I look down, how many hours have passed at point C? 3 of them. And how many miles have we driven in that amount of time? 180, right? We're just looking over. Interpreting, right? So we're putting a context to the number. And then after 4 hours will be our last one for this table. How many miles have we driven in 4 hours? 240. Right? Boom. We've filled out our table. And we're not going to worry about point E because I don't have room for point E, so we don't need it. So remember, if we're going to find K, right, that's the whole purpose of this. If we need to find K, that's going to be my next step. I'm going to do it right down here. Find, it's not the right color.
Oh, I have no room.
It's okay, you can go on to the next page. It's your notebook. What we're going to do is we're going to find K. Okay, I'm going to move this down so we can see. And in order for us to find K, we're going to take a look at the table. Okay, and what we're going to do is we're going to go up top to our X values, 0, 1, 2, 3, 4. I'm going to draw a little arrow from one box to the next. And I'm going to ask myself, how do I get from 1 to 2? What do I need to add to, or sorry, how do I get from 2 to 3? What do I need to add to 2 to give me 3? 1, right? So I'm going to write plus 1. And down on the Y's, what do I need to add to 120 to get to 180? 60. So I'm going to write plus 60. Okay? Very, very simple, yes? From one box to the next is 60 on the bottom. From one box to the next is 1 up on the top. And what this tells us is that in 1 hour, we can drive 60 miles, right? Which is what Zach said earlier. You're going 60 miles per hour. And that's what K is going to represent, okay? So we know that K is equal to Y over X, right? Because it's the ratio of Y's to X's. I'm going to drop this down so we can see in the back. So for Y, we're going to plug in the number 60. For X, we're going to plug in the number 1. Okay? And 60 has the units of miles. 1 has the units of hours. This tells us we're going at a constant speed of 60 miles every 1 hour, right? So after 2 hours, you've gone 120 miles.
But what if you need to stop and get gas or charge your
That's
car?
that's something we're not factoring into this. That's in real life. Yes, you will need to stop and stretch your legs and use the bathroom and get all that stuff. But in this, we're going at a constant speed, meaning we're not changing. We're not going faster. We're not going slower. We're going 60 miles an hour the whole entire way. All right. 60 miles in 1 hour. So we can say that. I'm going to finish this off. K is equal to, what is 60 over 1? How can we simplify that?
60.
Just 60, right? And the units are going to be miles per hour. I know this isn't the most exciting thing in the world, okay? I appreciate you guys staying with me. So remember, K is the constant of proportionality, right? So what K here tells us is that we're going at a constant speed of 60 miles per hour. Now, we had to put Y over X, right? The phrase, why aren't you over your X? If we had put X over Y, that wouldn't have made any sense. 1 over 60, then you'd be going 1/60th of a mile per hour or something like that. I don't even know because it's confusing. It doesn't make sense. So we just want to put Y over X just like that. When it comes to the homework or the assignment that we're about to get, let me show you just this is a lot. I'm going to show you a very simple example of kind of what you're going to see on the assignment so we know what we're doing, okay? Make a quick little table. Boom, boom, boom. Just like that. X on the top, Y on the bottom. This will be a great example for us. So on top we got X representing the number of minutes. On the bottom we've got Y representing the number of push-ups. Did they make you guys count your push-ups in PE?
Yeah.
Fun.
Angelique could only do it.
Good people.
Really, dude. What'd you
All right.
say?
So you're going to see a table like this with some units for X, some units for Y, and a bunch of numbers, right? And all you're going to have to do today is find K. Now K, like we said, is equal to Y over X. We're going to use that same formula each time. So Y, is Y my number of minutes or my number of push-ups for the letter Y? Number of push-ups, right? So I'm going to do a little arrow here. How do I get from 20 push-ups to 40 push-ups? What am I adding?
20.
You add 20.
I'm looking for a number. We're adding 20, right? Plus 20, right? If I've done 20 push-ups and I want to do 40, I have to do plus 20 more.
2 more sets of 10.
And from 2 minutes to 4 minutes, how much time has passed there? From 2 minutes to 4 minutes. 2 minutes. So I'm going to write plus 2. So my X is equal to 2. My Y is equal to 20. What number am I going to put on top of my fraction? The 20 or the 2? The 20. And on the bottom is going to go my what? 2. Okay, I'll pause there for a second. What does 20 represent in this problem? Push-ups. What does 2 represent? Minutes. So I'm going to add those on there too. 20 push-ups in 2 minutes. Can we simplify 20 over 2 at all?
Yes.
Yeah, what's 20 divided by 2? 10. Right? 20 over 2 simplifies to 10 over 1. So, based on this table, you can do 10 push-ups in 1 minute. Yeah.
Do we have to simplify it?
Yes, absolutely. You always want the bottom number to be 1, and we'll explain why in a later day. But just know for now, you always want your X on the bottom to be 1, okay? 10 push-ups in 1 minute. So our answer here is going to be K equals 10. There you go. Push-ups per minute. Exactly right. 10 push-ups per minute. All right? So that's exactly what your assignment worksheet number 4 is going to look like here in just a second. Okay? We got a good amount of time to work. I think it's only like 11 questions on there, so it shouldn't take too long.